The evolution of climate grid modeling. Climate grid modeling has undergone significant advancements since its inception, shaping our understanding of climate dynamics. This summary outlines the historical developments, characteristics, and implications of early climate models, emphasizing their role in predicting climate change. Historical milestones in climate modeling. The journey of climate grid modeling began in the early 20th century and has been marked by several key milestones that laid the groundwork for modern climate science. 1922, the conceptual grid. Lewis Fry Richardson proposed the revolutionary idea of dividing the atmosphere into a grid of cells in his work weather prediction by numerical process. This concept aimed to calculate changes in air pressure, wind velocity, and temperature, setting the stage for future developments in numerical weather prediction. 1950s, first numerical weather forecast. The advent of early computers allowed scientists to automate Richardson's manual grid calculations. This transition enabled faster forecasts, though they were still limited in scope and accuracy compared to modern standards. 1967, first climate model. Syukuro, Manabe, and Richard Wetherald developed the first comprehensive computer model that simulated the entire climate system. This model linked atmospheric convection with CO2-induced temperature changes, marking a significant advancement in understanding the relationship between greenhouse gases and climate. 1970s, global grids. The early 1970s saw the establishment of 3D grids that covered the entire Earth. Notably, James Hansen's models accurately predicted future surface warming despite their coarse resolution. These models demonstrated the potential of grid-based simulations in climate forecasting. Characteristics of early climate grids. Early climate grids were characterized by specific features that defined their structure and functionality. Resolution. The horizontal grid spacing of early models was approximately 500 kilometers. This coarse resolution limited the detail and accuracy of localized climate predictions, but was sufficient for understanding global trends. Structure. Early climate models comprised between 50,000 to 150,000 grid points, with vertical layers representing the atmosphere and, later, ocean layers. These layers were essential for simulating different atmospheric and oceanic processes. Purpose. The primary aim of these grids was to solve differential equations governing fluid motion, radiation, and energy balance. By doing so, they could simulate climate conditions over extended periods, providing insights into long-term climate behavior. The impact of early climate models. The early climate models and grids had a profound impact on the field of climate science, influencing both research and policy. Predictive power. Despite their limitations, these early models accurately predicted global warming trends, underscoring the importance of numerical methods in climate science. Their findings laid the groundwork for understanding anthropogenic climate change. Foundation for modern models. The principles established by early climate models continue to inform the development of contemporary climate simulations. Advances in computational power and modeling techniques have led to higher resolution models that can capture more complex interactions within the climate system. Scientific communication. The success of early climate models also facilitated better communication of climate science to policymakers and the public. By providing tangible predictions, scientists were able to advocate for awareness and action regarding climate change, challenges, and limitations. While early climate grid modeling was groundbreaking, it was not without its challenges and limitations. Coarse resolution. The 500 kilometers resolution meant that fine-scale phenomena, such as localized weather events and regional climate variations, were often overlooked. This limitation necessitated further advancements in grid resolution. Simplified physics. Early models relied on simplified representations of physical processes, which sometimes led to inaccuracies in predictions. As understanding of climate dynamics improved, so too did the need for more sophisticated modeling approaches. Data limitations. The availability and quality of observational data during the early years of climate modeling posed challenges. Limited data restricted the ability to validate models and refine predictions accurately. Conclusion. The legacy of early climate grid modeling. The evolution of climate grid modeling from the 1920s to the 1970s represents a critical period in the development of climate science. Early models, despite their limitations, provided essential insights into the dynamics of the Earth's climate system and the impacts of greenhouse gas emissions. The foundational principles established during this time continue to shape modern climate research and policy, highlighting the importance of ongoing advancements in modeling techniques. As we move forward in addressing climate change, the lessons learned from early climate grid modeling remain invaluable.